Hello, student. So this is another question from your tutorial 3, and this is the 8th question. Okay, 8th question. Okay. So this problem is related with Fourier series property. Okay, Fourier series property. Property is okay. Fourier series property is Fourier series properties. Okay, under this topic, we have discussed some properties related with Fourier series coefficients. Okay, so these properties are related with Fourier series coefficients. Okay. Coefficients. Okay. So I think we have learned 3 or 4 properties. Okay. Under this, we have learned linearity property, linearity property. Okay, linearity property. Then we have learned time reversal property. And we have learned about time shifting property. Okay, time shifting property. Time shifting property. Okay. And I think this question will be mostly based on these 3 properties related with Fourier series coefficients. Okay, so to have a quick recap, so we will see what are these. Okay, so if we have a signal xt, okay, so this will be a periodic signal xt. Okay, and if we express this as a Fourier series, of exponential terms. Okay, so let's say that Fourier series coefficients are ak. Okay, so these coefficients are variable. Okay, so we denoted this xt's coefficients as ak. In the same way, if we have a yt periodic signal, okay, and if we get the Fourier series of this signal, okay, and let's say that the coefficients are bk. Okay, so this k can be minus infinity to plus infinity integer. Okay, and also here also k is equal to k. K will be minus infinity to plus infinity, some some integers. Okay, minus 1, 0, 1, 2, 3, so on. Okay, so if we have another signal Zt, okay, and say that Zt is constructed using these 2 signals. Okay, and it is, if we multiply this signal by scalar, okay, by some value plus, and if we we add and if we multiply this signal by another variable, not variable, constant, scalar. Okay, and if this signal is constructed like this, okay, we add these 2 signal with some weight. Okay, and the Fourier coefficients of Zt will be, okay, ak plus B BK. Okay, so this is the linearity property. Linearity property. Okay, linearity property. Okay, and if we get, so this is the linearity property. Okay, this is the linearity property. Okay, and if we get the time reverse of this signal, for example, if we get the time reverse signal of xt, that will be x minus t, no? We have learned these time transformation techniques in our previous topic, okay, uh, which uh, which uh, has been included in our learning outcome too. Okay, so we have already learned these things. Okay, so if we get the time reverse signal, the Fourier coefficients of this time reverse signal will be a minus t. Okay, in the same way, if we get the y minus t, that is time reverse signal of the yt, the Fourier series coefficients will be b minus t. Okay, and this is the time reversal property. Time reversal property. Okay, this is the time reversal property. Okay, and if we shift this xt by some value, by some time value, let's say t naught. Okay, so this is the shifted signal. Okay, and the Fourier series of this shifted signal will be a k e minus j k omega naught t. This omega naught is 2 pi by t naught. Okay, the fundamental frequency. Okay, and in the same manner, if we get y t minus t naught, if we shifted the y signal, we will have bk e to the power minus jk omega naught. Sorry, here t naught. Okay, it should be t naught. Okay, this will be t naught. This shifted time. Okay, and here also it will be t naught. Okay, and if it is plus, if this is plus, this will be plus. Okay, okay. So this is time shifting property. Time shifting property. Okay, I think it is enough to have that knowledge to do this question. Okay, if you have this knowledge and if you can remember these three properties, I think you can easily do this question. Okay, so let's move to the question. Okay, so here we are given a signal, and we are given some signal. There are 1, 2, 3, 4, 5 5 different signals. Okay, and we are asked to find the Fourier coefficients, Fourier series coefficients of these signal. Okay, Fourier series coefficients. Okay, so let's take the first signal. Okay, take here. Okay, so I take the first signal. Okay, the first signal is RT. Okay, the first signal is RT. Let's say that this signal Fourier coefficients are AK. Okay, if you go in this manner, I think it will be easy. Okay, so let's assume that the signal, this RT signals Fourier coefficients are AK. Okay, so you can see that so this is the signal. Okay, so this is the signal. So you can see that there are 1, 2, 3, 4. There are 4 components. Okay. Okay. So if you look at the signal, you can see that this signal is already as a collection of exponential terms. No, this RT signal is already a sum of some exponential terms. No, complex exponential terms. Complex exponential term. Okay. So actually, so we no need to find the Fourier series of this RT, okay, because it is already given, okay. So we can, so if we found the if we find the uh, if we find the Fourier series representation of this RT, we express this RT as a collection of complex exponential terms, okay, and it is already there, okay, it is already in that form, okay. So we no need to find the Fourier series representation, it is given, okay. So this is the Fourier series representation of this RT, okay. uh, so we have given this RT, okay, and you can see that there are 5 components, 1, 1, 2, 3, 4, okay. So this is constant, okay. So you already know that it is a DC component, okay, and it should be a 0, the 0th component, okay. So that is 1, okay, and you can see that here it is J5T and E minus J5T, okay. So actually for this question, you have to give the omega naught, okay. You have to give the omega naught, okay. So otherwise we can't find the K value. So we need the omega naught value, fundamental frequency, okay. So here we can assume that, okay, the lowest omega naught, lowest omega of this component is the omega naught, okay. So let's assume actually that data should be given in this question, okay. Mistakenly I didn't put that one, okay. So I should have given that data, okay. Otherwise sometime you may face to determine this omega naught, okay. So so say that we have given that, okay, lowest angular frequency, okay, lowest angular frequency is the fundamental angular frequency, okay. Lowest angular frequency is the fundamental angular frequency, okay. So let's assume that this is already given, okay. This is already given, okay. So you can see that here the 5 is the lowest omega, okay, lowest angular frequency. So let's we can assume that omega naught is equal 5, okay. So this is 5, okay. So omega naught is equal 5, okay. So for this question, for this signal, the fundamental frequency is 5, okay. Now we can find the Fourier coefficients, okay. So you can see that it is 5. So here the multiplier is 1, no? Okay. So this should be A1, okay, the first harmonic, okay. So it should be A1 and A1, okay. So this is the exponential terms and this is the coefficients J, okay. So this J will be your Fourier series coefficients, okay. So here A1 is equal to J, okay. In the same manner, if you consider this component, okay, so here it is minus 5. Minus 5 means minus 1, 5T, okay. So this is omega naught, okay. So K is equal to minus 1. Okay. I have written the signal here. Okay, I will written the signal here. So our signal is RT, okay, and it is given as 1 plus J e to the power J 5T plus J e minus J 5T plus E J2 E J 10T. Okay. 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 So we have already assumed that the Fourier coefficients of this RT are AK. Okay. So so this will be the 0th coefficients. Okay, so it is a constant. Okay, so here the exponential terms will be 0. That means k is equal to 0. Okay, and the k is equal to 0. So e to the power, it will be 0, and e to the power 0 is 1. Okay, so this will be a0. Okay, so a0 is 1. Okay, and if you consider this term, okay, so this is so here this is your exponential terms. Okay, exponential terms, t is there. Okay, so this is if we so we know that omega naught is 5 here. Okay, so this is j1 5t, j1 5t. So this k is 1. Okay, so it is a1. So this is the exponential terms. Okay, it consists the t. Okay, so this will be the coefficients j. Okay, and here if you consider this one, okay, so we can write this as j minus 1 5t. Okay, so this 5 is omega naught, and this will be k. Okay, so k is equal to minus 1. Okay, so that means it is the minus 1 harmonic. Okay, so it will be a minus 1. So this will be the exponential terms, and this will be the coefficients. No, so it will be j. Okay, and if you consider this one, you can write this as j 2 5t. Okay, so this k is equal to 2 here. Okay, so it is a2. No, that term is a2. So here we have a2 is equal to, okay, so you can see that here this term include the t. Okay, so this t is the variable. No? Okay, so this has the t. Okay, so this will be your exponential terms, e j k omega naught t. Okay, so this will be your exponential terms. Okay, and you can see that here there are no any t terms. Okay, the time variable is not there. Okay, so this will be a constant. Okay, so this is exponential terms, but it is a constant, ej2. Okay, so this will be the coefficients, no, because that one is the constant. Okay, so a2 is ej2. Okay, so we have 4 terms. Okay, 4 coefficients. Okay, we have 1 2 3 4 terms. Okay, so related with those 4 exponential terms, we have 4 coefficients. Okay, so these are the coefficients. Okay, so these are Fourier coefficients. Okay, so we have already find that. Okay. And we are given another signal, that is qt. Okay, qt is equal to 2j ej3t minus 2j e minus j3t. Okay, so the lowest angular frequency is t. Okay, so for this signal, omega naught also will be 3. Okay, and you can see that if this is 3, this will be so let's say that the Fourier coefficients of this qt is bk. Okay, so we have so you can see that this is so omega naught is 3. Okay, so the k is equal to 1 here. Okay, so k is equal to 1 here. So here k is equal to 1. Okay, so so that is b1. Okay, so this is the exponential terms. Okay, and this will be the coefficients. Okay, so b1 will be 2j. Okay, and if you consider this one, it is minus j 3 theta. No, it's minus j 3 theta, minus j 3 theta. Okay, so 3 is the omega naught. Okay, so you can write this as j, okay, minus 1 3t. Okay, so the k is equal to minus 1 here. Okay, so that is b minus 1. So the coefficients is b minus 1, that is minus 2j. Okay, so the coefficients is minus 2j. Okay, so if you ask to draw the magnitude plot, okay, so very easily you can draw the magnitude plot here. Okay, so we have k. Okay, and we have k is equal to 0 1 -1 and 2. Okay, so these are the k value here. Okay, so a0 is 1. A0 is 1. So here we have 1. Okay, so that is the magnitude 1. Okay, so if you get the magnitude of this one, 1 is square plus 0 is square root. So it will be 1 again. Okay, so it is 1. Okay, and if you find the a1 magnitude, okay, for this one, it is j. So that is you have to so so this is complete imaginary part. Okay, so here we have 1 here. Okay, 1j, 0 plus 1j. Okay, so if you get the magnitude here, okay, so you have to 0 square plus 1 is square root. So 1 is square root, again you have 1 here. Okay, so here the magnitude is also 1. Okay, and if you consider this one a -1, it is j. In the same manner you can put here 1. Okay, so this is totally imaginary number. Okay, so the magnitude will be 0 plus 1 is square root. Okay, so it will be again 1. Okay, and for this terms k is equal to 2, it is ej2. Okay, so you can see that this is in polar form. Okay, polar form. Okay, so here the 1 is already here. Okay, so this will be the magnitude, no? So this complex number is in polar form. Okay, so the magnitude is 1 here, and here also the magnitude is 1. Okay, so this will be your magnitude plot. Okay, and if you write the phase plot here, okay, if you write the phase plot here, okay, so this is totally real number. Okay, for real number the phase is 0. Okay, so now you are going to plot the phase of AK. Okay, so phase is 0. Okay, for this 0, phase is 0. Okay, now k is equal to 1. K is equal to 1. Okay, so it is totally imaginary number, so it will be in this axis. Okay, so the phase will be 90, no, 5 by 2. Okay, so if you plot the phase here, it will be 5 by 2. Okay, and this is the k. Okay, and for this one, actually this is not related with the question. Okay, I just give you a quick recap. Okay, because in the exam sometime you may ask to draw the magnitude plot. Okay, so you have to have that idea. Okay, okay, so here you have uh, so sorry, here we are going to plot the magnitude plot of this coefficients. Okay, so if we get the phase plot of this coefficients, this AK coefficients. Okay, the phase of AK. Okay, so 0, it is totally real number. Okay, so you know that real number are in this axis. Okay, this is the real axis. Okay, so the phase shift is 0. The phase is 0. Okay, so here the phase is 0. Okay, at the 0th at k is equal to 0, phase is 0. Okay, and at a is equal to 1. Okay, so it is imaginary number, totally imaginary number, so it is in this axis. Okay, so the phase will be, it is in this axis, phase will be 90, no, here 90. So the phase of this is 5 by 2. Okay, and if you consider a -1, so here it is also plus j. Okay, so that means it is in this axis and it is here. Okay, in this line. Okay, so the phase will be again 5 by 2. Okay, that is for -1. Okay, so for 2, this is in polar coordination. Okay, so this will be the phase, no, so the phase is 2 here. Okay, so this will be the phase plot of this signal. Okay, and in the same manner you can draw the phase plot and magnitude plot for BK. Okay, and if you consider the BK, if you consider the magnitude plot, the magnitude of BK. Okay, so the K's are B1 and B minus. Okay, so 1 and minus. So here we have only K value -1 and 1. Okay, So at 1, k is equal to at 1, this will be the coefficients 2j. Okay, so it is totally imaginary number. Okay, so if you find the magnitude, it will be 0 square plus, okay, 2 is square I square root. Okay, so it is again will be 2. Okay, so here you have 2, at plus 1 you have 2. Okay, and for minus 1 you can see that uh, it is also 0 square plus minus 2 square root. Okay, again it will be 2. Okay, so for minus 1 also, case minus 1 also, the magnitude of this coefficients is 2. Okay, so this is the magnitude plot for this variable, for this coefficients. Okay, and if you plot the phase plot, okay, phase plot, okay, so we have k minus 1 and 1. Okay, so at minus 1 the value is 2j. Okay, so if you draw the complex span, here it is. Okay, so this is the imaginary axis. So here this coefficients is in this line. Okay, so the phase is 5 by 2. Okay, so here the phase is 5 by 2. And for this one it is minus 2 in this way. Okay, so phase is here. Okay, so it is in minus direction, so this phase is minus 5 by 2. Okay, and this will be minus 5 by 2. Okay, and this is the phase of the bk. Okay, and this is the magnitude plot and this is the phase plot. Okay, so you can easily draw magnitude plot and phase plot if you are asked, but here it is not asked. Okay, and so only we need these coefficients. Okay, only we need these coefficients. Okay. Okay. Okay, now we are given another signal, that is ZT. Okay, so ZT is constructed using these two signal. Okay, and weighted and sum. No, so one is 5 RT and 6 QT. Okay, so ZT is 5 RT and 6 QT. Okay, so you are asked to find the Fourier coefficients of this signal. Okay, for this signal you can use the linearity property directly. Okay, okay, so you can use the linearity property. Let's say that the for this signal is at t. Okay, the coefficients are ck. Okay, coefficients are ck, so you can use the linearity property here directly. Okay, so ck is equal to so rt coefficients are ak. Okay, so you have 5 ak plus the coefficients of qt we take as bk. No, so it is 6 bk. Okay, so ck is equal to this. Okay, so now we have to find the ck values for ck. So we will start from a. Okay, so we have a0. Okay, so we have a0. Okay, so we have so the c0 also should be there. Okay, c0 is equal to 5 a0 plus 6 b0. Okay, so you can see that there are no value for b0. Okay, there are no value for b0, only we have b1 and b minus 1. Okay, so b0 is 0. No, okay, so this will be 0. Okay, so what is the c naught value? It is 5 a naught. Okay, so a naught is 1. A naught is 1. Okay, a naught is 1. So 5a1, 5 1, that means 5. Okay, so this is the zeroth coefficients of this ZT signal. Okay, and if you consider a minus 1, okay, a minus 1, so we have c minus 1 also. No, c minus 1 also. So c minus 1 will be 5 a minus 1 plus 6 b minus 1. Okay, so we have a value for b minus 1. What is that? That is minus 2j. Okay, so a minus 1 is j. Okay, a minus 1 is j and b minus 1 is minus 2j. Okay, so we have 5j plus 6 minus 2j. Okay, so this will be minus 12j. Minus 12j plus 5j, you have minus 7j. Okay, so this will be the c minus 1. Okay, so this will be the c minus 1. Okay, and here let's take a1. Okay, so c1 also should be there. Okay, c1 also should be there. So c1 is equal to 5a1 plus 6b1. Okay, 6b1. Okay, so 5a1, a1 is equal to j. Okay, so 5a1, 5j, we have 5j plus 6b1. What is b1? It is plus 2j. Okay, so it is 6 multiplied by 2j. Okay, so we have 12j here and 5j, you have 17j. Okay, so this is the C1 coefficients. Okay, and also we have a2. Okay, also we have a2. Okay, and a2 is 5 a2 plus 6 b2. Okay, so you know that b2, there are no coefficients for b2, so this will be 0, and the a, so this is c2. Okay, so c2 will be 5a2. Okay, so a2 is e to the power j2. Okay, so the coefficients is 5 e to the power j2. Okay, so these are the coefficients for zt. Okay, so we have b1 and b minus 1. So c1, c minus 1 are related with that coefficients. Okay, so those are already there. Okay, so these 4, 1, 2, 3, 4, these 4 will be the coefficients of zt. Okay, here also you can plot the magnitude plot and phase plot very easily. Okay, so the magnitude here is 5. For magnitude, this for minus 7, the magnitude will be 7. For plus 17, the magnitude will be plus 70. Okay, and this is in polar coordinate, and this will be the magnitude 5. Okay, so you can very easily draw the magnitude plot, and you can also draw the phase plot. Okay, so phase is here 0 because it is totally real number. Okay, so here it is minus j, so phase will be minus 5 by 2. It is 17j, totally plus number. Okay, so here it will be plus 5 by 2. Okay, and for this phase will be this 2. Okay, because this is in polar form. Okay, so you can easily write the phase plot and phase plot and magnitude plot. Okay, so we have done this one also. Okay, now we have to find another signal, that is xt. Okay, so that is the time reverse signal of zt. Okay, time reverse signal of zt. Okay, so so we know that zt. Okay, for zt we have ck coefficients. Okay, so so here the xt is equal to z minus t. Okay, xt is equal to z minus t. Okay, z minus t. Okay, so you can use the time reversal property here. Time reversal property. Time reversal property. Okay, using the time reversal property, the coefficients of z minus t will be a minus k. Okay, so here we have ak and here a minus k. Okay, so we have to find the a minus k. Okay, a minus k. Okay, So let's say that for z minus t, the coefficients are, let's say that it is some value, okay, and qk or something, okay, qk, okay. So we know that using the time reversal property, qk is equal to a minus k, okay. So this is the time reversal property, okay. Now we have to find these coefficients, okay. And now you can see that we have for k we have my for this qk, okay. So let's say that this is capital K, okay. So for this capital K we have the minus of ak, okay, these coefficients, the minus of these coefficients, okay. So if you consider this one c naught, here k is equal to 0 and minus k also will be 0, okay. So it is will be qk, q0, okay, zeroth component, and it is equal to 5. No, it is equal to 5 because c naught is equal to 5, okay. And so here the c minus 1, okay. So here k is equal to minus 1, okay. So here k is equal to minus 1, okay. So so you have to get the minus of k, okay. So that will be plus 1, okay. So corresponding to this signal, time reverse signal, okay, that coefficients will be q1, okay. That coefficient will be k is equal to 1 because you have to get the minus sign, okay. So this will be q1, okay. This will be q1, okay. And q1 is equal to the minus, k is equal to minus 1, that is minus 70, okay. So here you have q1 as minus 70, okay. And for this one you can see that k is equal to, so here c1, okay. So k is equal to 1, okay. So you have to get the a minus k, okay, a minus k, okay. So that means k is equal to minus 1, okay. So that is equal to this qk, no, okay. So q1, okay, q1. So here it is minus 1, okay, q minus 1, and q1, okay. So here it is minus 1, okay. Q1 will be this minus, sorry, this will be q1. This qk is equal to a minus k, okay. So q1 corresponding to q1, it should be minus 1, okay, okay. So this is okay, minus 1, okay. So this is this should be q plus, okay. Sorry, I'm sorry. This will be q1, okay. This will be q1. The k is equal to 1 here, okay. So corresponding to that one, the sign so in the ZT signal we have to get the minus 1k, okay. So that is equal to minus 7k, okay. So here we are going to find the q1, okay. Q minus 1, okay, q minus 1, okay, because here the here k is equal to 1, so we have to get the minus 1, so it will be q minus 1, and q minus 1 will be 17j, okay, 17j, okay. And here you can see that it is c is equal to 2, okay, k is equal to 2, okay, and you have to get the minus k, that is minus 2, okay. So you have to get the minus k, that is minus 2, okay. So q minus 2, q minus 2 will be, q minus 2 will be this 5 e to the power j, j2, 5 e to the power j2, Okay, so these are the coefficients for Z minus T. Okay, so you have used the time reversal property. Okay. Okay. You have to get the minus value here. So here 0. So so here the a minus 1, that means that will be q1, that is equal to 7k. Okay, so a1, so here it should be related to a minus 1. Okay, so it is q minus 1, that is 7k, and here a2. Okay, so q2, so that is related to minus 2, and this is the coefficients. Okay, I think this is correct. Okay. Uh, and now we are asked to find this one. Okay, so it is, we have to use the time shifting property. Okay, so yt is equal to yt is equal to z t minus 6. Okay, so it is a time shifted signal. Okay, so you can use the time reversal property here. Okay, so we know that zt, for zt we have find the coefficients, that is ck. Okay, now we have to find the coefficients for z t minus t minus 6. Okay, so you can use the time shifting property, time shifting property, time shifting property. Okay, using the time shifting property, you can say that zt minus 6 is equal to ck e to the power minus j k omega naught of the t. Here it will be 6. Okay, so here minus sign, and here also will be minus. Okay, so let's say that this is equal to some value lk or something. So lk will be the coefficients. Okay, so lk is equal to this value using the time shifting property. Okay, now we have to find this L value. Okay, okay, before that we have to verify what is the omega naught here. Okay. So here we have to verify what is the omega naught. Okay, so we have to find, so we have zt. Okay, so this is the zt. Okay, and we have to find the omega naught of this zt. Okay, so how to find that one? Okay, so you can see that zt is made using by adding this signal and this signal. Okay, so we have already find the Fourier coefficients of this kind, fundamental period of this kind of signal. Okay, fundamental period of this kind of signal we have already find. Okay, so if you consider this signal, RT, okay, what is the fundamental frequency here? That is 5. No, we take omega naught as 5. Okay, so that is the fundamental frequency. And what is T naught? T naught is equal to 2.5 by omega. Okay, it here again. Okay, so before that I will write the coefficients. Okay, so this omega naught we have to estimate. Okay, so I keep it for a while. Okay, I'm going to estimate this omega naught. Okay, but before that I will write the coefficients here. Okay, so you can see that here we have C0, C minus 1, C1, C2. Okay, I will write this one here. We have C0, okay, that is 5, C minus 1, that is minus 7J, no? C minus 1, that is minus 7J, C plus 1, 17J. So this is minus 7j, C plus 1, that is 17j. Okay, and we have C2, that is, as I can remember, 5EJ2. No, these are the coefficients for ZT. Okay, so these are the coefficients for ZT signal. Okay, these are the coefficients for C naught is 5, C minus 1, minus 7j, C1, 17j, C2, 5e to the power j2. C minus 1, minus 7j, C1, 17j, C2, 5e to the power j2. Okay. Okay. No? Okay. So using the time shifting property, we can easily find the coefficients of ZT minus 6. Okay. So these are equal to this one. Okay. Okay. Let's say that L0. So for 0, we have L0. Okay. So we have C0 here. E to the power k is equal to 0. So we have 0 here. So we have C0. C0 is 5. Okay. So L0 is 5. Okay. So this will be the YT signal. Okay. So coefficients of YT is LK. Okay. So L0 is 5. Okay. We have found this one. Okay. And L minus 1. L minus 1, that is equal to C minus 1 e to the power k is minus 1. So minus 1 minus 1. So it will be plus j. Okay. Omega naught 6. Okay. So we have to estimate this omega naught. Okay. So I will write the answer here with the omega naught. Okay. So C minus 1 will be minus 7j. Okay. So you have minus 7j e to the power j omega naught 6. Okay. Omega naught 6. Okay. So this is a constant. Okay. Because here it is 6. Okay. So we have this value. Okay, so we have this value. You can further simplify this, and you can express this as like this in a polar form, or you can express this as like this, x plus y, iy as a in a Cartesian coordinate. Okay, but you no need to do simplification, further simplification. If you can find the value up to this level, you can get the full marks. Okay, so that is L minus 1. Okay, and L plus 1. Okay, so it will be C1 e to the power minus j. The k is omega, k is 1 here, omega naught 6. Okay, so we have C1 17j, and it will be e j omega naught 6, and it will be minus. Okay, so this will be the L1. Okay, in the same manner, L2 will be C2 e to the power minus j 2 omega naught 6. Okay, so C2 is equal to 5 ej2. Okay, and you have e to the power minus j. So 2 plus 2 into 6, it will be 12 omega naught. Okay, and you can use you can also simplify this one. So this will be plus j2. Okay, but you no need to simplify up to this level. It is okay. Okay, so here we have found the L0, L minus 1, L1, and L2. Okay, so these are the corresponding coefficients for C0, C minus 1, C plus 1, and C2. Okay, so these are the coefficients. So here also we have 4 coefficients for YT. Okay, so we have already find that using the time shifting property. Okay, now how to estimate this omega naught? Okay, so I will tell you how to estimate this one. Okay, so actually we have already we have already done this kind of question. Okay, so here you know that for this signal, okay, for this signal, omega naught is equal to 5. Okay, because we have to get the lowest frequency, lowest omega as the omega naught. Okay, so 5 is the lowest angular frequency for this signal. Okay, so we can take omega naught as 5. Okay, so what is the let's say that that is 1 omega 1. So this will be the first signal. Let's say that this will be the first signal, and the fundamental angular frequency of this first signal is omega 1. Okay, so that is equal to 5. Okay, let's say that fundamental period of this signal is t1, and it is equal to 2 5 by omega 1. Okay, and it is equal to 2 5 by 5. Okay, so this will be the t1. Okay, for this signal. Okay, and if you consider this signal, the lowest frequency is 3. Okay, let's say that that is the second signal. So omega 2 is equal to 3. Okay, so you have t2 equal to 2 5 by omega 2. Okay, so this is the definition. Okay, so here you have 2 5 by 3. Okay, so you have found t1 and t2. Okay, so if you consider this one, you can see that this signal is a t is consist, okay, by adding these two signals. Okay, so this is the first signal and this is the second signal. Okay, so you have to you have add these two signal and you have multiplied some value with some value. Okay, so this will be always related with the amplitude of the signal. Okay, so this value. Okay, these are not affect to the period. Okay, period of angular frequency. Okay, those value are not affected. Okay, for this one, okay, so this is the first signal and the fundamentally fundamental period is t1, and this is the second signal, fundamental period is t2. Okay, so for a composite signal you have to take the ratio of this t1 and t2. Okay, so if you get the ratio, you will have 3 by 5. No, 3 by 5, because here 2 5 by 5 and 2 5 by 3, 2 5 2 5 cancel out, 3 will be go up. Okay, going up, so it will be 3 by 5. Okay, so this is rational, and you can see that this is the periodic. Okay, so this is a t also periodic signal. Okay, so is a t also a periodic signal, okay. I can remember that we have done this method for many sinusoidal signals, sine and cosine signal. Okay, but I can't remember we have done one or two examples related with the exponential terms. Okay, but you know that by using the Euler formula, this exponential terms also can be converted into a sine and cosine signal. Okay, so these are also sine and cosine again. Okay, so here for if you consider the exponential terms, you know that if we have this kind of ej omega naught t, this kind of signal a ej omega naught t, okay, so this will be the fundamental frequency. Okay, and t naught will be 2 5 by omega naught. Okay, we have learned these things. Okay. Okay, so I don't think you have confused. Okay, so if you have any problem, you can ask me. Okay. Okay, so this is rational and it will be ZT also will be the periodic signal. So what is the period? So period can be verified as 5t1 is equal to 3t2. Okay, so this will be the period. No, let's say that it is t0 for ZT. Okay, so the frequency, the fundamental period of ZT is t0. Okay, so t0 is equal to 5t1, no, 3t2. Okay, so that means t0 is equal to 2 5, you know. Okay, 5t1, so it is multiplied by 5, 2 5, or 3t2. So if you multiply by 3, you have 2 5. Okay, so this will be the fundamental period for for ZT. Okay, so ZT, okay, t0 is the fundamental period, fundamental period. Okay, and it is equal to 2 phi. Okay, so what is the omega naught? Omega naught is equal to 2 phi by T naught. Okay, so omega naught is equal to 1. Okay, so omega naught is equal to 1. Okay, for this signal is a T, the fundamental angular frequency is omega naught is 1. Okay, here it is 5 and here it is 3. So here it is 1. Okay, very easy. Okay, so what you have to do, you have to put 1 for this every term. Okay, you have to put 1 for this every term. Okay, okay. So we will stop here.